So the linear and nonlinear test closed yesterday. I think all of y'all got it turned in. I actually didn't have too many people that did not get it turned in across all my classes, which is good. So since that closed yesterday and you don't have anything due next week, that means unless you're doing the extra credit assignment, you don't have anything to work on this week. Did I already go over the extra credit assignment with y'all? Okay. So that would be on that video then. All right. Just remember that if you are going to do the extra credit assignment, that you got to turn it in by December the 8th. Got to turn it in by Monday. If you need to, you can bring it by my office. You can mail it to me, whatever's easier for you. The one I've gotten already was emailed, so that'll work out good. Okay, hop over to the statistics lab, and I'm going to pull up the notes for that. You go ahead and be looking at your grades that you got there. Oops, I didn't mean to pull that up yet. Getting ahead of myself here. I was talking with a Moodle administrator. I think one reason why it takes my pages so long to load is I reuse the same Moodle format every semester. And sometimes whenever you reset and import into the class, it pulls the entire question bank from each previous. So that's why I've got like duplicates. So I need to just go in there and clean it out during Christmas. So with statistics, we just kind of barely looked at the surface of it. We talked about mean, median, and mode. We did box plots with a 5-number summary, and we finished it out with scatter plots. So just kind of brushing through this real quick. Everybody should by now know how to do the average. Just add them up, divide by how many there are. Good deal there. Outliers do affect the average. We mentioned how zeros hurt you more than a 100 helps you, because the idea is to keep your grades high and not, let them fall too far, rather than start out low and have to try to pull them up. Median, middle value of an odd set, halfway point of an even set. So we mentioned that certain analytics like the median better because of the fact that outliers don't affect it. Now, there's things you can use it for and things that you can't use it for. You can't use median for grades because then it's just looking at the middle of your grades, right? And like I was talking with the class this morning, if you were using median for your grades and you wanted a 100, you'd basically have to make sure that all your grades were 100s, right? Because that way they're all the same. And if you had any kind of zero in there, or like I say, if you had a 0 and like a couple of 80s and then the majority of them are 100s, it's still going to affect your median a little bit. But yeah, it's just better to use the averages with that. Mode, most occurring value in the set. Remember, if there's not one, you put no mode. We talked about this again on Monday, going over the extra credit assignment, how some people's grades in their grade book, their mode is a 0, unfortunately, which is why if you do the extra credit assignment, you have to tell me what assignment you want it to go on. Outliers are in the extremes if they are considered outliers. We didn't really go over standard deviation to exactly find outliers, but you can kind of get an idea of it once you make the box plot. So again, here was an example of mean, median, and mode. When you have a set of numbers that's not in order, it's best to go ahead and put them in order, because 2 of your 3 measurements have to have them in order anyway. And if you're doing the 5-number summary that we're going to talk about next, it has to be in order if it's not already, because you have to do the median to split it into the 2 halves to get the other medians. So with the 5-number summary, we said, put them in order, get your lowest number, get your highest number, then find your median, then get your lower quartile, then get your upper quartile. But when you graph them, it goes in this order on the screen here. Lower extreme, lower quartile, median, upper quartile, upper extreme. Basically the lowest number to the highest number. And then of course quartiles are medians of the upper and lower halves. Don't do like I did that one year and forget that it was the median and think that it was the mean, and you get a number that's close but not exact. So box plot is a graphic that basically takes a big number set and organizes it into 5 numbers to kind of help you get an idea of what the trend of the numbers is doing. So that was what this was. And when you organize it this way, this sort of looks like an outlier compared to the rest of them. in terms of what the majority is doing. All right. So when we had ones like this on the assignment, you had to get your 5-number summary, then you had to make your scatter, I've done that all day, make your box plot, and then compare it to the answer choices. Scatter plots are a lot easier. You just have to tell, is it positive, is it negative, or is it not doing anything? If it's positive, both variables are increasing. If it's negative, one's increasing, one's decreasing. And if it's no relationship, maybe it's just a mess, maybe it's a curve, maybe it's straight up and down or straight horizontal. Basically, it's not leaning one way or another, so one is not affecting the other. And that was an example of a positive relationship. That was an example of a negative relationship. And this was just one of many examples of it being nothing, right? Okay, so let's hop over to your grades for that. Whew. Yeah, it is definitely too hot in here now because I'm starting to get a headache. So I'm going to try to go very, very quickly. Does that video not work? I bet there's an extra space in there that has to come out. And well, that's tomorrow's problem. Okay, so looking at your grades, right off the bat, are there any that you missed that you want clarification on? Or was this one pretty much okay? I think most people didn't have any trouble until we got to like 13, 14, the box plots. So number 1 is positive, number 2 is, number 3 is nothing. Remember when we graphed these that one day in Excel, and I told you that if you use Excel or Sheets or something like that, there's ways to get this thing called the R-squared value to pop up, and the closer that the R-squared value is to a 1, the more tightly correlated that it is. A linear graph, like a straight line, would have an R-squared value of exactly 1 because all the points have the same distance between them. But this one, they're just kind of clustered. But I think we kind of a guideline we use, like if you're checking it in Excel, would be if it's less than like a 0.5 on the R-squared, you could make a case for it not being correlated, right? Because it's a little bit too loose. But ones like this, these would have R-squareds of like 0.8, 0.9. They're pretty tight. All right. What happens to the age of a computer and its value? Right. Age goes up, value goes down. We said if you think of it as a phone instead of a computer, nobody would miss it, right? Height and body temperature of adults. Right, we got some medical folks in here, right? Yeah, that would be absolutely nothing. If I took all of your heights and charted them and then took your temperatures and charted them, that's basically going to be horizontal, right? The temperature, if I put the temperature on the left and your height across the bottom, that's going to make a horizontal graph, so there's no correlation there. We said that that's a reason why there's a healthy baseline for what your temperature should be. Unemployment rate and number of homeless people. I told you to think about the Great Depression with that one, so what would that be? Right. As the unemployment rate went up, the number of homeless people went up, right? So we learned that positive correlation does not always mean a good thing. Negative correlation doesn't always mean a bad thing. Anybody have any trouble finding the mean of the retirement age of those employees? Man, whoever retired at 50, good for them. Holy cow. Still got your rest of your life ahead of you. Anybody have any trouble finding the median here? The focus of this question was not so much like calculating it as it was knowing where it is, right? So there was an odd number set here, so it's clearly 55 for that one. If there was one more number or one less number, you would have to average the two in the middle, right? 9, was there a mode there? It was O. Think about it this way. If you've ever had a biology class of some kind and you didn't even look at the answer choices, what should the mode of that set be? It should be O, right? Now, granted, there are people that have like really unique blood types. My mom's blood type was that way. Hers was like an AB with some stuff on it. I don't know what they're called, but every time she had to have a blood infusion, they would have to order her blood from Chattanooga because the hospital didn't keep it.
I have AB
Yeah, it might have been that. Me, I'm just a regular old boring O. So anyway, number 10, weekly salaries of 16 people. So you had to get the 5-number summary here. Did anybody have any trouble with that one? I kind of cautioned you to start with because the answer choices are really close together apart from the first and last number because those are easy to find. So just be really, really careful. I've heard of some folks missing the ones that are coming up, the scatter plot ones, because there was one question where it had just one number off by 1 digit, and they missed it because of that. So just be very diligent. Anybody have any trouble with 11 or 12? Okay. How about 13? Anybody have any trouble with 13? Anybody? We did one of these together when we reviewed this, didn't we? Yeah. It wasn't this one. It was that.
I think it was the very last one.
Yeah.
It was me.
Right. We did that one this morning out at Andrews too, yeah, because I do remember that one. I figured out a trick with that one. As far as like scaling it, we went by 250 every time. That worked out a lot better. I still almost ran out of room, but it was better than trying to go by 100. All right, so nobody had any trouble with 13? Everybody's good there? Remember the trick with this. First, get your 5-number summary, and then check your graphs. Because if you get your 5-number summary first, you can usually knock out half the answers, right? And then, like with that last one we were talking about, which I guess was number 16, 17, that one, you knocked out 2 graphs that looked exactly the same. So it was either one or the other, and that helped to narrow it down. So that's probably the case with this, with all of these. So anybody have any trouble on 14? Anybody miss it? Everybody good on 14? Okay. 15? Any trouble there? And then, of course, we should already have this one ironed out because we did it before. All right, good. Okie doke. Plodding right along here. All right. So then with probability, nope, I didn't download it, okay. Oh, I didn't download. All right. I never should have put these on the same file. Okay, so with probability, we looked at theoretical and relative frequency. We said theoretical is like a hypotenuse. You're looking at what should happen. With relative frequency, you're actually collecting data, things like that. So we said this morning, if you flip a coin 6 times, how many heads should you get? 3, right? But you didn't flip it, right? It said if you flipped it. So that's theoretical. Then if, say, you go ahead and flip it, and maybe you got 2 out of 6 or 4 out of 6, or maybe you got 3. As long as it's hovering right around what the theoretical should be, you don't have any reason to suspect that coin's messed up or misprinted or anything of that sort. And then subjective is based off of your personal experiences. And then events not occurring, we said that the way you figure out something not occurring is you figure out that it will, and then subtract it from 1. So the way that you calculate these for theoretical and relative frequency, it's basically the same, it's just different terminology. So probability, it's the total number of possible outcomes on the bottom, and the number of ways that what you're looking for can occur happens on the top. It's a lot easier for these if you figure out what your bottom number is first, and then that will help you narrow down your top number. Like this one here on the screen about the birthdays. If you figure out that your total number of outcomes is 365, and then say someone says probability of someone born in October, then it would be 31 over 365, or if they said April, it would be 30 over 365. February, I wouldn't really mess with that one because it would just depend on what year it was, I guess. Then relative frequency, same thing. So let's say that you're testing DNA, looking for some sort of marker, and you tested 10 samples, and so that would be your number of observations, right? The 10 samples. And then if that marker showed up 6 times, that would go in the top. So it would be like 60%, all right? In other words, theoretical is what should happen, relative frequency is what did happen. So this was the weather one. All right, subjective probability, we said this is based on your experience. I think there's a 100% chance I'm going to be late because I overslept by 30 minutes or, something like that. Or if you're, like some of my family members and just chronically late everywhere you go, then that's probably closer to 100, right? Again, the fairness test, all that was that you figure out the theoretical, then you do the relative frequency or check the relative frequency and see if it's close enough to say that, yeah, nothing was bothering this, there wasn't anything messing it up. So the formula for probability of something not happening was 1 minus the probability that it will. So that was a trick with these, find the probability that it will, then subtract it from 1, and then there you go. Easy peasy. All right? So if we pull up the worksheet for this, whenever it decides to load. Okay. Did anybody miss number 1? Has everybody figured out that on the worksheets that look like this, number 1 is usually your gimme? Hopefully nobody put anything except for D, right? All right, so again, just to help you get the ball rolling. 2, die with 6 sides is rolled, probability to get number less than 5. Did anybody have any trouble with that one? Just remember that, be careful to see if it says less than or at most. At most means less than or equal to. So that would be including the 5, and that would be A. But the one for this one was D, I think. 3, bag has 6 red, 3 blue, 7 green marbles. If you're trying to get one that's blue, what's that probability? So you had to add them all up, then figure out how many were blue and see if it would reduce, right? 4 was one that I had to help you get started on because we didn't have one like it in the notes. You're rolling 2 6-sided dice and you're trying to find a probability that the 2 numbers will make a 4. So you have to multiply all the outcomes, right? 6 by 6. And then that would be your bottom number, and then you would think of how many combinations make a 4. But don't list them out. Please don't list them out. Okay, so number 5, 6, and 7 was switching to relative frequency probability. On number 5, what was your bottom number there? What was your total number of observations on number 5? Yeah. 1801 was your bottom number, 212 was your top number, and then they wanted you to turn it into a decimal. Number 6, you got 61 heads when you tossed a coin 100 times. If you don't know whether the coin is fair, which if you got 61, it probably isn't. But if you didn't know whether it was or not, what's the probability that the next toss will be heads? Well, that's the other main benefit of relative frequency is you use it to make predictions, right? Going back to the DNA samples, if you tested 10 samples looking for something and it showed up 7 times, then there's a 70% chance that the 11th sample will have whatever you're looking for also, right? Just going off of these rules. 7, in a poll, I'm not going to read that whole thing, hell. What was your bottom number on this one? Right, yeah. Number 7, when you did it the first time, I told you be careful with the numbers. They're not what you think they are. The bottom number was not shown in this question because 481 said they were, 421 said they weren't. So you had to add those together to get a bottom number of 902. And then you don't even use that 421. It's 481 over 902, and it came out to be somewhere around 50. I think it was like 50. Actually, I don't remember what it was, but it's around 50%. 8, 9, and 10 we're all probability of something not happening. So again, just figure out the probability that it will, subtract it from 1, boom, you got it. All right, no, not a big deal. Any questions about this one? All right. All righty. Pull up your test. Your statistics I can't say that word. Statistics and probability test. See what you got. See if you missed any that we need to go over real quick. They're working on our HVAC because it's been out for 2 days. Yeah, that's why.
Sounds like almost everything is always broken in this place.
I think this is the oldest building. I think so. Yeah. It was something when they redid the roof. Something didn't get connected back together. I don't know what. I was just half listening when they told me because I was freezing to death. So. All right, everybody good on the statistics and probability test? Anybody have one that we need to look at? Everybody good? Okay. So I'm going to go on the assumption that if you did miss one, you know what you did. All right. Let's hope so. Okay. The most recent one that we did was linear functions. So I'm going to pull that up. Okay. So with this one, we mentioned that the difference between this one and the scatter plots was every point in a linear graph has the same exact distance between it. That's why it makes a straight line. If you were to try to put an r-squared value on it, it would make exactly a 1. Linear functions are written in slope-intercept form, and the reason why it's linear is because it, again, is changing at the same rate between each point, which means that the slope is constant. Slope-intercept form, you've got y equals mx plus or minus b. Remember, y is your output. It's dependent. It depends on everything that happens over here to the x. M is your slope, x is your input, and it's independent. It could be given to you, or you could pluck it out of thin air, whatever you want to do. And then plus or minus b is your y-intercept. The b is the most important part of this, even though it doesn't take the longest to find unless they didn't give it to you. So it's the most important part because if you're making a graph, it's the first one that you mark, unless you're doing it by the points. If you're reading a graph, it's the first one you look for. So from there, we move to the slope formula. Remember, if you still get crossed up about where the numbers go in the formula, label them. Label your first point, x1, y1, your second point, x2, y2, and then just pop them in where they go there. Leave the minuses at first. Don't try to change anything too early because you're liable to lose negatives that way. And after you substitute it, then you can go back and fix it. We'll look at more of that here in a minute. Input or function tables. Remember, x goes in, y comes out, and the main purpose of this is to help you get ordered pairs. There might be questions that say which one of these ordered pairs fits on this line, and what you'll do is you'll run the x and see if you get the y. If you don't, then it doesn't fit on that line. Same thing there. Then we move to the difference between graphing with points or graphing with the equation. Graphing with points is easier, but it takes longer. Graphing with the equation is quicker, but you have to know where your starting point is and where you're going to go to your second point. So if I didn't see this at all, I would know that I started at 4, and then I went up to right 1 to get to the second point, which is how you read them. All right, this one we're working on the assumption that this one was pre-made. So we didn't have anything as far as an equation. The question might have said which one of these functions matches this graph. So the first thing you're looking for is always your y-intercept. You're always going to look for where it crosses. And then from that, to get to the second point, we went down to, right to get there, making the slope triangle or walking the slope, whatever you want to call it. And then we had to reduce it. And we've got y equals negative 1x plus 4 or y equals negative x plus 4. And I said the first time, if this was a traditional class where I was giving you paper assignments and you wrote y equals negative 1x plus 4, I would take it because I don't care if it's there or not. That's just splitting hairs. But your answer choices that they're provided are going to say it's simplified as y equals negative x plus 4. So here was more practice finding the slope, and this was mainly, like I said, to give you practice with, minus negatives and things like that. So anytime that you have subtraction of a negative, that's the same thing as just adding it, right? Because they're opposites. So, don't forget your integer rules there. We said that if it comes out to be a fraction, leave it, even if it's improper, because most of the time it will be. But if it's one like this, 2 over 1, what you leave it as depends on the question. If they gave it to you as a bunch of equations, you take that 1 off and look for a 2. But if this is something that you have to find on a graph, leave it as 2 over 1. So point slope form, I mentioned on Monday, this is what is on that extra credit paper. So you've got to use point slope form to get the entire function on that extra credit paper, then graph it from there. Or you could find the point and follow slope to the second point, draw the line that way, then figure out what the equation is. A couple ways to go about it. But the main focus of point slope form is to find the y-intercept when it's not given to you. So y minus y1 equals m times x minus x1. So we got some examples here that are like the ones that you are going to see if you decide to do the extra credit paper. You're going to have one point, you're going to have the slope, and they're going to be asked to run all that through point slope form and get the equation. Now, I don't know if you looked at that extra credit paper long enough, but some of those slopes are not easy. Some of them are pretty big fractions. So just be very careful there. Now, the ones that take the longest are when you are presented with a question that says, here's 2 points, we want the whole equation. So when that happens, you have to find the slope first, then you have to run it through point slope form. And it's not that it's difficult work, we said, but this does take up the most space. So that's why on that extra credit thing at the bottom, I told you to just write the equation, and you can put the work on another piece of paper or on the back of it. If you're doing it, it's optional. Okay, so pull up your grade for that. I'm going to pull up the student copy. All right, so you had questions where you had to find out what the slope was, then you had to, there are some where you had to walk it on a graph, you had to use point slope form, point slope form with 1 point and the slope, or with 2 points and no slope. So it came in a bunch of different versions, but all of it was stuff that we had in the notes. So did anybody miss any of these that we need double checked? Or did you miss it but know what you did? I'm not naive enough to think that everybody's just like knocking it out of the park with every single assignment. So if you're having questions about something, now's the time to ask, or, like Sheldon Cooper says, suffer in silence. All right, so the nonlinear part of this mainly focused on 2 things. We focused on what it looks like if you have it's not going to work, let's do this. If you have an exponent on your x, that's going to make it nonlinear, right? It's not going to be a straight line anymore because the growth won't be linear, won't be constant, it'll be exponential. It'll basically be, doubling itself. So that's why it makes a curve, but it's also why the curve swoops back around, because of things like, positive 5 and negative 5 both having the same square, right? Positive 5 squared, negative 5 squared both make 25. So that's why it comes back around like this. And then the other one that we looked at was absolute value. Absolute value makes a V, but with absolute value, you don't have to worry about an exponent, you have to worry about these grouping symbols. So just whenever you run these through, just go back to order of operations, okay, with the quadratic one or the exponential one, take care of your exponent first, do your multiplying, do your adding, then you're good to go. With the absolute value, get the absolute value first, then just follow the rest of it after that. All right? Okay, so pull up your grade for that one. Student copy for this one really wasn't all that bad. This one was just kind of designed to kind of finish out the regular labs. All right, so there was a lot of substitution on this one. It was mainly going, it was easy work on the surface, but it was mainly just going back through to make sure that you knew how to, add, subtract, multiply, and divide integers. So don't forget your rules for that. It practiced with, recognizing what kind of slope something has off of the appearance of the graph. Same rules apply for scatter plots. We said with 15 and 16 that those points that they gave you are not consecutive, meaning that they're not the next whole number of points in order. So when you find the slope for those, you had to reduce it. Then you had some other questions like 19 and 20, which I was a little surprised to find it stumped some people. On number 19, y equals negative 3/5 x minus 8. What's the slope of that equation? Of this one right here. What's the slope of that equation?
-8, right? No.
Nope, it is not -8. Negative 3/5 is the slope. Remember, it's called slope intercept form. It's telling you the order in the name. But the reason why you would say -8 is because -8 is the most important number in that, because if I had told you to graph that, that's the first thing you'd put down, right? So I get it, don't worry about it. Just make sure that you have that sorted before you take the final. Same thing here. Now that we know what we know, what's the slope of y equals 5x plus 7? Yeah, we answered that one a whole lot quicker, didn't we? These here, again, with exponents, just remember your order of operations. All right. Let me ask you this one. On number 24, y equals the absolute value of 2x. What's the y-intercept of that function? So you know how we said if something that says y equals x plus 5, that it's a slope of 1, but it's not showing because that's not considered simplified? What is not showing after y equals the absolute value of 2x? Not a 1, but you're not far off. Whenever the y-intercept is 0, they don't show it because it just means it's going to run right through the middle of your coordinate plane. So just something to be on the lookout for in case they try to throw you a curveball and give you one that says, what's the y-intercept of y equals 3/5 x, right? So in that case, you know that you're just going to start at 0 and there you go. Okay, the test for this one that closed yesterday. Pull your grade up for that. If you have a question about one on there, now would be the time to ask it. Give you a minute to look that up. I don't know how some of y'all do anything with those nails. My sister-in-law took my daughter to get her nails done one day, and she came back with some, remember that scene from Mrs. Doubtfire when he was like that? She had some of them things on. And I was like, how are you going to do your homework? Because I'm the practical thinker in the house. How are you going to do normal functions and not cut yourself to pieces? But we don't think about these things. All we think about is, ooh. That's as far as it got. Yeah, okay. You are not helping. Anyway, all right. Linear test, linear, nonlinear test. Any questions on that? Well, and my mom didn't have long nails. She hated them because she's always working outside and she didn't want to break them, so I get it. Okay, so just to remind you for next week. Oh, also one thing that's kind of popped up today. These videos are available to you. Looks like they're working. Maybe one or two of them aren't. Kind of hard to tell anymore. But if any of the videos aren't working, let me know. I have had someone tell me that they could not get them to work on their computer, and given that it's, this time of year, I know what kind of computer that person uses, and it is a Mac, and Macs just have this issue. Sometimes they work and sometimes they don't. So if you can't get it to work, try a different device, preferably one that is non-Apple, because Apple just doesn't jive with our stuff. It just never has. Like if you order a new computer, if you're an employee here, you order a computer, they won't even give you the option to buy one because they can't service it. They have to send it to the Apple people because they got Apple Care and all that. Okay, so final is going to open up on Monday. Don't forget that if you do the extra credit, it's also due on Monday. This part, that's what I forgot to do today. I got back in my office after going through all my classes, trying to find all the missing grades. And I was like, there was something else that I meant to do in Moodle, but I totally forgot about it. That's what it was. The correct answers will show after the due date passes, right? You'll know what it is after you're done. The reason why I had that in there is based off the old test format when I didn't have it pull in random questions. Basically, I had 4 different test versions, and everybody was getting pretty much the same questions, just in a different order, and I didn't want them knowing what the answers were until everybody had done it. All right? But you'll be taking a test pulling from about 450 questions, so I'm not terribly worried about it. And hopefully, like I mentioned on Monday, the chance of getting repeat questions should be pretty slim. Should be. We will see what the relative frequency on that is whenever we get done with it. But like I told you during the year when it was too late to fix it, if you do get a repeat question, I just hope you get it right twice. That's all we can do, and then try to get it ready for the spring. Okay. So again, one more time. Oh, what did I do that for? One last thing to remember, because a couple of you were asking about it earlier today. I think that the course evaluations are still open. I don't know for sure. I haven't really gotten any emails that said they're closed, or I haven't even gotten like reminder emails that say, hey, so-and-so hasn't done their evaluation yet. Remember that it's not for a grade, but it is something that we appreciate that you would do, because people do look at those and collect the data and see who needs to be taken out back and flogged. I'm just kidding. They don't do that. And if they did, they wouldn't tell me. So, all right. So if you've not got that done, make sure you get that done. And a lot of people forget that you have to do one for every class. So if you're in 143 and 045Q, you've got to do one for both of those. Okay? Or you are expected to do one for both of those. We'll put it that way.